All right, so today we're talking about 7-segment displays. 7-segment displays look like this. You can use them to display the decimal numbers from 0 to 9 and some alphabet characters. There's two kinds of 7-segment displays: common anode and common cathode. And the only real difference is how you wire them. Then we're also going to learn how to select resistor values for 7-segment displays. Okay, so a 7-segment display, it's just a thing that groups together 8 LEDs, 7 for the segments and 1 for a decimal point. And each segment is labeled A through G, and they're always in the same spot. It always starts on the top with A, and then we go clockwise. So A, B, C, D, E, F, and then G is in the middle. Then decimal point would be at the end. But you have to get used to where this segment names are. A is on the top, B and C on the right side, D on the bottom, E and F on the left side, and then G in the middle. And these are here's common cathode and common anode, and this is how they're often wired. Common cathode, you are going to connect these two middle pins on the top and the bottom will go to ground. And then all these other pins, if whatever pin is connected to the power supply, that will light up that segment. Common anode is you have the power supply connected in both places at the chip, down here and up here. And then the segments that light up would be the ones that you run to ground. So that's the difference between common cathode and common anode. Common cathode, you're running both of these pins to ground, and then you would wire these to power supply in order to light them up. And then it's the opposite with common anode. You're running power supply in here, and then you'll connect these to the ground to light up individual segments. So here are like the decimal digits that you can display, 0 through 9, some of the alpha characters that we can do. And there's some fun words that you can say, that you can write with these. There are other ones that you may have written with a calculator as a joke, but we're going to try to avoid those if they're naughty. How to understand, okay, so in order to understand how 7-segment displays work, you've got to remember how LEDs work. So there has to be a difference in voltage potential. There has to be about it takes about a 1.5 volts to light up your LED. So that means that you have to have more charge on one side than on the other. So, but the amount of current flowing through the LED determines the brightness. And the amount of current is controlled by a resistor, which we would put like after this. So the resistor controls the amount of current that flows through, but you have to have about 1.5 volts to get it to go through. Okay, so here is these little circuits here are showing a common anode, but only one of the little LEDs inside the 7-segment display. So this is common anode, so you can see that it's hooked up to power supply. And then, you got 5 volts here, you got a 220 ohm resistor, and then over here you have another 5 volt VCC power supply. So for this one, you can see that you have 5 volts on this side of the LED, but you also have 5 volts on that side of the LED. So there's no potential. There's no, if you had 5 volts over here and 0 volts over there, then the current wants to pass through. But if you have 5 volts on both sides, nothing's going to happen. But when you turn the switch to connect to ground, now you have 5 volts on this side, nothing on that side, so the current will flow through. And the resistor controls how much current will come through. You'll have 1.5 volts across here, And since you have a total of 5 volts, you would have 1.5 volts lighting up the LED, and then you would have 3.5 volts going across the resistor. So the smaller resistance value you pick, the brighter it will be. But you have to be careful. If you make it too small, then there will be too much current and it'll blow up your LED. And if you make your resistance too big, then you won't have enough current flowing through and it'll be very dim and hard to see. So this was common anode. So that's common anode. You'll be running power to this middle pin on the top and bottom, and then connecting out to ground through your circuit. Okay, so here is an example for us to work on. This is a common anode 7-segment display. And we need to try to figure out what value would show up, what would be displayed. So let's take a look. So this is common anode. So that means that any one of these terminals down here that gets connected to ground, those will light up. So we just have to kind of trace them through. Let me see if I can get a highlighter here. So A, if we look at A, so that's a pen, get a highlighter. Okay, so A, we look at the terminal A, it hits the resistor, and then it goes and connects back up to the 5-volt power supply. So we've got 5 volts here and 5 volts there, so that A is not going to light up. But on B is connected to ground. So we've got from our 5-volt power supply going through B that connects to ground. So B will light up. So segment B will light up, and segment B is right here, right? It's vertical, top right. Okay, now let's look at C. C comes down here, goes through the resistor, and it connects to ground. So C will also be lit up. Segment C. This. And then let's take a look at segment D. Segment D, nope, it doesn't connect to ground. So segment D will not be lit up. Neither will segment E. Segment E is also hooked back to the power supply. But it looks like F and G both go to ground. So F and G will both be lit up. So F and G, so we got A on the top, then B, C, D on the bottom. E is going to not be lit up, but F over here and G right here will be lit up. So remember, on a 7-segment display, it's A, B, C, D, E, F, and G. So we had A not lit up. This was A. This was B. Wait, B went through, so B was lit up. C was lit up. D was not. E was not. But F and G were lit up. So we only lit up B, C, F, and G, which makes the letter or the number 4. So this is with a common anode, right? The power supply going in, then any terminal that connects to ground will light up. So here, now let's look at common cathode. Common cathode means that all the LEDs are connected to ground, and the only ones that light up are the ones that are going to be connected to our power supply. So here we've got power supply going through a resistor, and then our LED, and then ground. So this is a complete circuit. This one will light up. Here we've got ground, an LED, a resistor, and then it's connected to ground. So there's no power supply. This one's not going to light up. We basically have on this side of the we have 5 volts over here and 0 volts over there. So that tells us it's going to light up. The power is going to run through there. Here we've got 0 volts on this side and 0 volts on that side, so nothing's going to happen. So on these, you're running a ground cable into the top and bottom pins. Got ground coming in here. And then the ones that are going to, segments that'll light up are the ones that get wired to a power supply. So let's look at an example and see what's going to be lit up here. Now this one is common cathode. So you can see that our ground is running in here. And then the only segments that are going to light up are the ones that get connected to the power supply. So we just need to see which ones connect to the power supply. We've got, so here's our power supply. It's connected to A and B, but not C. It's connected to D and E, but not F. It is connected to G. So we've got A should be lit up, B should be lit up, not C. D should be lit up, E should be lit up, not F, but G should be lit up. So A would be lit. So here's A. B would be lit. There's B. C would not be lit, but D would be lit. E would be lit. F would not be lit, but G would be lit. So this circuit would give us the number 2. Okay, so then the next part is figuring out what resistor to use. Obviously, if you're using the exact same component that we're using in this lesson, you'd probably want to use a 220 ohm resistor. But we don't know if we're going to be using the same exact ones, so we need to, we would need to, whatever component we were using, we would have to look at the data sheet for it to get some information to figure out. Then we would have to do a little bit of math to figure out what resistance resistor we should select. So the resistor value determines the amount of current that will flow through the LED, meaning it'll control the brightness. This is why resistors are sometimes called current limiting resistors. The amount of current determines how luminous or bright the LED will be. If the resistor is too large, the current will be too small and the LED will not be bright enough to see. If the resistor is too small, the current will be too large and the LED can be damaged. So how do you select the correct value? We have to get some information off of the data sheet for the 7-segment display that we're using. So to review a little bit of circuit theory that we did a while ago, this diagram down here is just one of the LEDs in a 7-segment display. And we talked about before how it takes 1.5 volts to light up the LED. So by Kirchhoff's voltage law, the voltages will add up. So if you have 5 volts total and then you have a 1.5 volt drop across here, that means that there's 3.5 volts left to be moving across the resistor. So then you remember that we can use Ohm's law, where V equals IR, or R equals V divided by I. So we know that there's 3.5 volts going across that resistor. And now we can figure out our resistance based on how much current we want to flow through. And the data sheets will tell us the right amount of current to flow through. depending on how bright we want it to be. So here's one of the ways that the data sheet can tell you. They give you this little graph right here is one of the ways they share that information with us. Relative luminous intensity, normalize 1 amp to one luminous intensity unit, I guess, at 10 milliamps. So if we looked at our data sheet and it had this graph on it, and told us that we needed, in order to get, and say we wanted to get a 1.5 luminosity. That's kind of average, apparently. That means that we follow the graph, right? That means we need 15 milliamps of current flowing through there. So then we would do 3.5 volts divided by 15 milliamps. And then you'd have to remember that when you do this in your calculator, you should be doing volts divided by amps. So in your calculator, you're really doing 3.5 divided by 0.015. Because 3.5 volts, 15 milliamps is 0.015 amps. And so when you do volts divided by amps, that'll give you ohms. So then whatever you get for that, you're going to just pick, they're standardized, and you just pick the one closest to it. So using this same information, what if we wanted it to be brighter, like a value of 2.5? So what we would do is we would find 2.5 on our luminous side, trace that over to see how many milliamps, and that's 25 milliamps. So then we remember it's the same situation. So we still had 3.5 volts going through the resistor, but now instead of, we want it to be brighter. So we wanted a more luminosity. So that means, 25 milliamps is is the current that we need. So then let's figure out what resistor would give us that current. So we're going to be doing 3.5 volts divided by 0.025 amps. And we grab a calculator. 3.5 divided by 0.025 is 140. So about 140 ohms. And that makes sense because before it was like 230 ohms, about 220, to get this one that was a little bit dimmer. To make it brighter, you would need less resistance. So 140 ohms, and then they will tell you that the closest standard value to that would be 150 ohms. So you don't have to memorize the closest standard, but when you do your calculation, you're going to then go to like your drawer of resistors, whatever, and pick the value that's closest to that. Okay, so that's how we figure the resistance. Let me go ahead and stop the video.